You ready? You guys ready to be done? You're almost P2s. You thought you were P3s, and but now you're P2. But it's all good. You're halfway. Is there a halfway party? I think we don't call it that anymore, right?
Nope.
No halfway party.
It's not a last one. Well, we're having it still. It's gonna be called pharmacist loading.
We call it a different thing, yeah. It's loading time. That's interesting.
Because not all of us are halfway.
Yeah, some people are more than halfway. Some people, well, you're all at least halfway, though, aren't you?
Traditionally halfway.
I wondered what that was. Oh, fun. It's this Friday. Oh, I have to go to Columbus. I don't know. Okay. Are we ready? We've got 24. I think there's 29 in here, so well, they're supposed to be. Everybody join that's going to join. All right, let's go. Please choose the sketch that appropriately describes the relationship between your elimination rate constant and clearance. This should be a gimme. Remember to label your axes appropriately. I've only asked you this like 15 times already, right? In some different way. All right. Justin jumps out to the early lead. All right. Most of you got this right. Let's take a look at this. Okay. When we think about the relationship between K and clearance, one of the big reasons I emphasize this early on is so that you understand that K is determined by clearance and volume together, right? So when you rearrange that equation and use V times K to equal clearance, you all understand that volume does not determine clearance. K does not determine clearance, right? Even though we do use that equation of clearance being equal to V times K, I want you to understand clearly who's driving the bus and who is not, right? So that's why I emphasize this. So the independent variable, when you're looking at the relationship between clearance and K, the independent variable is, everyone says, clearance. Therefore, clearance goes on the x-axis because that's where our independent variable goes, unless you're talking about economics. I learned because my son was an economics major and they do things crazy different, wrong. They do it wrong, backward. Just kidding. But in science, we put the independent variable on the x-axis. So clearance is driving the bus here and determines K, right? And so K goes on our y-axis. And then to determine what the shape of the relationship is, we think as clearance increases, what's happening to our K? It also is increasing, isn't it? It's a proportional relationship. So that's why that first one is correct. The second one is incorrect because why? The relationship is correct, but what's incorrect? The independent versus dependent is inverted here, right? So that's why the second one is incorrect. The third one, both things are wrong, right? You have the independent versus dependent messed up, and you have the wrong relationship, right? So sorry, whoever put C, you're in the weeds a little bit, or maybe you just guessed to get it out of the way. And D, what's wrong with that one? The axes are correct, but the relationship is wrong. Okay, good. You ready for the next one? if your desired peak to trough ratio is approximately 4:1, so you want your peak to be 4 times your minimum, your trough. And you can see how we use this in dosing now, right? Depending on what our goals are. Like you may say, I want a peak to trough ratio of 2:1 or 4:1 or 10:1, right? So you can use that to figure out how many half-lives you're going to need to be apart as far as your dosing intervals go. And I want you to think this way, right? You can always put some numbers to these equations, right? Put some numbers to these equations. Pick a peak and then make your trough 4 times less, right? 1 trough times 4 to get your peak. And then think about what's happening between those two numbers. Justin maintains his lead and Will is right on his heels. All right, how did we get this wrong? Okay. Is it keyed wrong? Okay. What did you guys say? 2, that should be right. Did you get it right? Okay, so it is keyed, right? So tell me, why did you say 2, Olivia? Teach us.
So personally, I do say
You-
picture in my head. I don't
okay.
think it would make sense if I say it out loud, but
Go ahead, give us
I
a
was
try.
thinking, like, the top is the combination between 4 to 1. Half-life, and it's gonna be that.
Yes, that's perfect thinking. When you do 1 half-life, what's the peak to trough relationship? 2:1. And when you do 2 half-lives, if you put numbers to it, let's say our peak is 10. What's it gonna be in 1 half-life? 5. So that's a 2:1, right? And what's it gonna be in another half-life? 2.5. That's a 4:1, isn't it? Which is what the question is asking. That's 2 half-lives, right? Your thinking in your head and the picture in your head was exactly right. Okay, do you know how to solve those now and think about those? What's it gonna be if we have 3 half-lives? 8:1. 8:1. Well, let's put some numbers to it. Let's make it a little bigger number. Let's say our peak is 60. In 1 half-life, it's gonna be 30. In another half-life, it's gonna be 15. So 15 to 60 is, what's 60 divided by 15? Wait, we need 1 more half-life, sorry. Then it's gonna be 7.5. So what's 60 to 7.5? 8, right? So you can always put numbers. Good, Shamaka? Okay, this one, remember, I try to fool you on these. I try to fool you. I've been trying, I tried, and for the most part, your equation sheet has the dependent variable on the left, not 100% of the time, but most of the time. And I try to fool you by writing it as if the variable on the left is the dependent variable, but it's not. You have to understand what the relationship is rather than just look at that left-handed, the variable on the left hand. Okay, so that's tricky. I'm trying to trick you to test whether you understand. Well, cilantro took the lead there. All right, so good. Most of you got it. Okay, does clearance determine volume? Shamaka, did you say no? Oh, I thought you said something. Who said something? I heard no. And you're right, Eden. Why? Clearance does not determine volume, right? What does determine volume? Plasma protein binding, tissue protein binding, right? Think of your VSS equation, right? Clearance doesn't determine volume. Does half-life determine volume? No. Again, it's protein binding, right? So we know that volume is not the dependent variable here. But what is? Clearance? Is clearance determined by volume and half-life? No. Is half-life determined by volume and clearance? So clearance is half-life is the dependent variable here, right? Is everybody good on this? Because I will ask questions like this, and that hopefully will be a gimme, as long as you all have it clear in your head. Couple of you still fell for the whatever's on the left. Don't automatically say whatever on the left is dependent, because it really requires you to understand the relationship. This one should be easy. God bless you. So this is the first time I can tell you a peak to trough ratio being too small could put a patient at risk, like aminoglycosides, right? Because we need a high peak and a low trough. So, right? For the first time, I can talk to you about a real life example of that and have it make any sense. All right, time's up. Let's see how we did. Okay, Cilantro Wonderlick is still just a hair ahead of Justin. Wow, great job. Very impressed. Somebody had a little brain issue, but you all feel confident being able to do this, I'm sure. Okay, next question. All right, this is taking that concept of needing to increase dose rate or decrease whatever you need to do with dose rate and dose interval and putting some numbers to it. Cilantro is holding strong. Oh, Delaney and FU, the fraction unbound, jumped over a bunch of people because there were some problems here. Okay, so let's think about this. We're giving 2 grams every 12 hours, and we have an increase in volume of distribution. If it's just an isolated increase in volume of distribution, which is all you knew right at this point, you have an increase in volume of distribution. Is that going to affect your CSS average? So do we want to make a change in dose rate? No, right? And he's getting 4 grams a day. So we want him to still get 4 grams a day. Everybody good with that? We want him to end up with 4 grams a day. What is it again? An increase in volume of distribution. So will that affect your peak to trough ratio? Yes, because it's going to affect K, isn't it? What's going to happen to your K if you increase your volume of distribution? it's spreading out more, it's gonna take longer to get rid of it, it's gonna get slower, right? So here's your original peak to trough ratio, and as your K gets flatter, what happens? Can you physically see what's happening to the peak to trough ratio? It's going from peak to trough to peak to trough, getting smaller, isn't it? Our peak to trough ratio is getting smaller. In order to get that peak to trough ratio where it was, we can't change the slope, but we'll have to extend the dosing interval, right? If you have an increase in volume, what happens to your half-life? It increases, right? And again, if we think about dosing every half-life, we're going to increase our dosing interval, if that helps. I think that's the easiest way to think about it, but it's up to you, whatever works for you. So we're gonna go from 12 hours to 24 hours. So we're gonna dose them once a day, and we already said we're gonna keep the dose rate the same at 4 grams a day. So it should be 4 grams every 24 hours. Is everybody good with that? Another dependent, independent variable situation. Hopefully this is easy. I pray this is 100%. Is a drug's clearance dependent upon the volume of distribution? Is a drug's clearance dependent upon volume of distribution? If you think so, you would say true. If you don't think so, you would say false. Please. Cilantro, Holds, Delaney, and Fraction Unbound, and all right. Well, the two here. You two, I'm worried, unless you're just trying to not to make sure that we're not perfect in every way, even though we are. You have to understand this. A drug's clearance, no. What is clearance dependent upon? Depends upon the organ, but it's always blood flow and extraction efficiency, Q times E. Clearance is always Q times E. Is volume in that? Is volume part of that? No, volume is the distribution of the drug. It has nothing to do with clearance, which is why, I shouldn't say nothing to do with it, but their independence. This is where the problem with saying clearance is equal to V times K comes in, because people think that volume determines clearance. No, it does not. They think that K determines clearance. No, it does not. What determines clearance? Blood flow, enzyme activity, your secretion sites, your reabsorption, right? Depending on whether it's hepatic or renal, and high and low and all the things, right? Is this like 100% clear? Okay. Eden says yes, we can go on. The F, which is bioavailability, as you know, why it's F, I don't know, increases for a drug in a patient. What would you expect to happen? Choose all that apply. So what does the bioavailability affect? What does bioavailability affect? Oh, alrighty, cilantro holding strong, 100%, excellent. Absolutely, because bioavailability is a determinant of CSS average, drug in over drug out. Is K dependent upon bioavailability? No, it's just clearance and volume, right? Half-life, same thing. Remember, half-life is just the inverse of K, so same determinants. Peak to trough ratio, also determined by K, and dose interval, which we control. None of these things involve bioavailability. Good. The area of the curve and CSS average of a drug has decreased. Should be have, huh? What could cause this? What could cause this? They both have decreased. Oh, looks like fraction unbound has surpassed. All right, so very good. Everybody did very well on this. So if the area under the curve and CSS average have decreased, both the CSS average is actually a function of the area under the curve. And maybe I was just thinking, should I have added this to your equation sheet just for an understanding piece? CSS average is calculated. If you were a worker in a drug company where you're trying to figure out the kinetics of a new drug, you would do the area under the curve and at steady state, and you divide that by tau, and it gives you the average concentration. CSS average is determined when you actually measure it, is really determined by the area of the curve. So it's a snapshot of the area of the curve. The CSS average is not the average of the peak and the trough. No, it'd probably be close, but the average is by using that exposure piece. It's the average exposure over that time period. So they really are determined by the same things, right? The equations are the same. We know that CSS average is bioavailable dose rate over clearance. Area under the curve is bioavailable dose over clearance, isn't it? They're really very, very the same determinants. So in order for both of them to go up, we know that bioavailability is a determinant of both. If bioavailability goes up, the area under the curve and the CSS average will go up, right? But in this case, we're going down. Sorry, we're going down. So if they go down, bioavailability, that'll cause a decrease in CSS average and area under the curve, won't it? The other determinant is drug out, which is clearance. So what would have to happen to have the CSS average decrease? The clearance would have to increase, right? So increased clearance is the other answer. Are you guys good with that? Yeah, you like it, Shamaka? Is everything crystal clear on this stuff? Good. CSS average is good. We like the CSS average, but the peak to trough ratio is too large, putting the patient at risk for toxicity at the beginning of the interval and lack of efficacy at the end of the interval. How do you want to adjust? You're going to change the dose rate and dose interval. All right, Eden is starting to climb the ladder there. All right, very good. Most of you guys got this right. If the CSS average of the drug is acceptable, are we going to change the dose rate? Right away, say no change in dose rate, right? But the peak to trough ratio is too large, too large. Can we change the slope? No. What can we do? We can chop it up into smaller pieces, more like a constant infusion, however you want to look at it. You can think of the picture. You can think of the peak to trough ratio is you're going to just chop it up into smaller pieces, which means your dose interval is going to decrease, right? And I think